Hi everyone, my name is Matias. I'm from the National University of Córdoba, and I'm going to talk about performance variability in zero-shot classification. Zero-shot classification is the task of learning predictors for classes not seen during training, which means that the set of train and test categories are disjoint. To be able to learn this kind of classifiers, it is necessary to describe not only the images, but the categories in a suitable representation space. For instance, it is very common to describe the classes by a vector of visual attributes. Formally, the goal is to learn a mapping from the image representation to the class representation space from a given training set. And then to use this function to classify images from a new set of categories. The variability problem. To introduce the variability problem, it is important to mention that in literature, there is a predefined train test partition for each dataset. So the question we are addressing here is how much does the zero-shot classification performance vary over different class partitions? We ran two methods over different splits, and we found that there is a strong performance variability whether or not the class imbalance is considered. Actually, this variability is higher in coarse-grained datasets and lower in the fine-grained datasets. Another observation is that the accuracy comparison could bias the selection of one method over the other, even when their difference is not statistically significant. To check this hypothesis, we use a statistical significance test. The resulting p-values show that for the fine-grained cases, we can reject the null hypothesis for a fairly low confidence level. So, given the variability problem, the next step will be to try to mitigate it. A popular approach to reduce variability is by ensemble learning algorithms. We adapt the bagging technique by generating different subsets of categories to train each predictor. We learn n predictor, each of one is trained with a proportion S of the original set of categories. And then we combine all these predictors by some voting scheme. This table shows the result for 90 models and different sizes. As we can see, as the proportion S increases, the result approaches the baseline. In addition, the standard deviation may marginally decrease, but with a considerable loss in performance, which is more noticeable in the case of coarse-grained datasets. So the use of bagging technique doesn't lead to an increase in the overall zero-shot learning performance. Finally, our conclusions are as follows. Zero-shot classification strongly suffers from the variability problem with respect to the class partitioning. It is important to consider the variability to obtain a more comprehensive evaluation process. The ensemble learning is not enough to reduce the variability without losing precision. And as a general conclusion, we suggest that it's important to complement the evaluation of zero-shot classification by considering the performance variability.